Hi, welcome to Unacademy. This is Sivakrishna Jonna. Okay. Okay. Unacademy, best online education portal. Unacademy Plus. So benefits of this Plus program: premium content at affordable price, structured live courses, quizzes at regular intervals for self-analysis, batches for complete preparation, test series for DPPs, full length marks, etc. with analysis. Single subscription for unlimited SS. Everything under single plus subscription. Okay. These are the Unacademy Plus subscription details for EAMCET 2021 aspirants. So 12 months plan, it cost around 12,375 rupees per month, 1031 rupees. 6 months plan, it cost around 10,125 rupees per month, 1688 rupees. Very less amount and more benefit. Okay, all the benefits what I explained previously, all are applicable for this subscription. Use my code JSKLIVE, will get 10% discount on the subscription price. There is 1 month trial plan that costs around 2,250 rupees. For that also use my code JSKLIVE, will get 10% discount. Okay. Now recently they started this one EAMCET batch. EAMCET Rankers batch. EAMCET Rankers batch starts 24th December 2020. These are the educators dealing that program. Okay, it is also helpful. Now today's class, complete discussion on dipole momentum. So we know very well, no bond is 100% covalent and no bond is 100% ionic. Even ionic compound also have some covalent character. Okay, so now in this class I want to tell about discussion about dipole momentum. Before going to discuss on dipole momentum, we need to know more on dipole momentum. So how dipole momentum will come to a molecule? What are the uses of this dipole momentum? From the dipole momentum, what we will tell? These are the factors we are going to discuss in this class. Okay. So dipole momentum is represented with the symbol nu. Okay. Nu is equal to, we'll define nu as charge, product of charge and distance between the charge. Distance, charge q and a distance d, So Q into D is called dipole momentum, which has units dy. One, it is represented with capital D. D is equal to 3.33 into 10 power minus 30 coulomb charge unit, and meter is a distance unit, coulomb meter. Okay, so in electrostatic units also, it value 10 power minus 1 device is equal to 10 power minus 18 electrostatic ESU. 1 device is equal to 10 power minus 18 ESU centimeter. Electrostatic into centimeter. This is the dipole momentum. How a molecule will get dipole momentum? For that you need to know bond polarity. Bond polarity. For example, you take molecules like H2, Cl2, Br2, F2, O2, N2. These are all homodiatomic molecules. So in this case, between H and H, the electron and single bond is present, covalent bond. That single covalent bond electron cloud is symmetrically arranged between nuclei of the two H atoms. Why this electron cloud is symmetrically? Because this H atom electronegativities are same. Because of the same electronegativity, the electron cloud not move towards any of the atom. Even fluorine F2, F between F and F also the electron cloud will be present. That electron cloud will be symmetrically arranged between two F atoms. It is not more towards one F atom and less towards another F atom. Why? Because both F atoms have same electronegativity. So electronegativity definition itself is the ability of atoms to attract shared pair of electrons towards them. This electron cloud attracting ability of the atoms is known as electronegativity. Both have same ability. That's why electron cloud is symmetrically situated between the two atoms. That molecule or that bond is the bond between all these molecules. Bond is non-polar bond. Bond is non-polar. There is no partial positive and partial negative charge. Electron cloud equally symmetrically situated between two bonded atoms. Okay, so this type of bond is called non-polar bonds. There is no partial positive and partial negative charge. Okay, for example, if we take a diatomic heterodiatomic molecules like HF, HCl, HBr, in these the electron cloud is not symmetrically arranged between the bonded atoms. Electron cloud more towards the more electronegative atom, less towards the less electronegative atom. That's why more electronegative atom will get partial negative charge. Actually, this electron cloud shape will be like this, more towards the fluorine. So fluorine gets partial negative charge and H gets partial positive charge. In HCl also, the electron cloud more towards Cl, less towards hydrogen. In HBr also, electron cloud more towards Br, less towards hydrogen. Now there is a partiality, partial positive charge and negative charge present in the molecule. Such bonds are called polar bonds. So polar bonds. Okay. So now I am going to tell that in a homodiatomic molecule, it will be like that. Homodiatomic or heterodiatomic molecules, bond, if bond is polar bond, molecule is polar. If bond is non-polar bond, molecule is non-polar. But in polyatomic molecules, but in polyatomic molecules, bond polarity, polyatomic molecules, polarity of the molecule depends on resultant resultant dipole momentums of all bonds in the molecule. For example, for diatomic molecules, if delta En not equal to 0, then delta U not equal to 0. For polyatomic molecules, this if delta U not equal to 0 for a single bond, but given delta En not equal to 0, but delta U is equal to 0 or delta U not equal to 0. Okay, that is depends on net dipole momentum or nu r. Actually, this dipole momentum or a dipole is a vector quantity. It is represented by crossed arrow. Cross represents less electronegative atom. Arrow represents more electronegative atom. Even if when we are taking a H2O molecule, here O and H, O is more electronegative. Okay, the net resultant will be in this direction. Okay, so nu r, for example, if we have two vectors, dipole vectors are separated by, it is a nu1, it is a nu2, two dipole vectors separated by an angle theta, resultant dipole momentum nu r is equal to nu1 square plus nu2 square plus 2 nu1 nu2 cos theta. If cos theta value theta is equal to 0, cos theta value 1, and theta is equal to 180, cos theta is equal to minus 1. So now I will give you information that is, if theta is equal to 0, then nu r is maximum, and nu r is equal to nu1 plus nu2. Why? Because cos theta is equal to 1. So square root of nu1 square plus nu2 square, 2 nu1 nu2 is equal to will becomes nu1 nu2. If theta is equal to 180, then nu r is minimum. That means two vectors facing in opposite direction. Nu r is equal to nu1 minus nu2. Okay, because this is the resultant formulas. So in polyatomic molecules, dipole momentum depends on individual resultant dipole momentums of the different bonds in the molecule. Okay, for example, if you take C double bond CO2, it has which structure? Linear structure. C double bond O, C double bond O. Out of C and O, which is more electronegative? Oxygen. Okay, here oxygen. Dipole vectors in the direction. Both are separated by an angle 180. Now nu r, CO, here dipole vector CO, here also dipole vector CO. So both are nu1, it is nu2, both are equal. Nu1 is equal to nu2. Nu1 is equal to nu2. Okay, that is equal to, I am taken here nu. So new resultant is equal to what is a new resultant when cos theta is equal to 180, nu 1 minus nu 2, that is equal to nu minus nu is equal to 0. So even though bonds are polar, molecule is non-polar molecule. Nu is equal to 0, so it is a non-polar. So presence of polar bonds is not guaranteed the molecule is polar. Net resultant dipole momentum will decide the molecule whether polar or non-polar. Okay, CO2 is a non-polar. Next, for example, if we take PCl5, PCl5, is it polar or non-polar? PCl5. Okay, PCl5 have trigonal bipyramidal shape. Cl, Cl, Cl here, Cl. See this one. Out of P and Cl, which is more electronegative? Cl is more electronegative. So dipole vector pointing towards Cl. These two vectors facing opposite to each other, that means separated by 180. So this dipole vector and this dipole vector are cancels each other. Now coming to these two dipole vectors are separated by an angle of 120 degrees. Cos 120, how much? Cos 120 is equal to minus 1 by 2. So nu r is equal to nu 1 square plus nu 2 square plus 2 nu 1 nu 2 cos 120. So nu r is equal to, here nu 1 nu 2 both PCl bonds, so nu 1 is equal to nu 2, so that is equal to nu 1 square means nu square plus nu square plus 2 nu square into minus 1 by 2. 2 get cancelled. So resultant nu r is equal to minus nu 1 nu square plus nu square get cancelled. So it is equal to nu square, that is equal to nu. Resultant dipole momentum nu. So it is also having nu. Both are facing in opposite directions. So resultant dipole momentum nu is equal to 0 for this molecule. Even though it contains polar bonds, as it having regular geometry, its a dipole momentum is equal to 0. It is a regular structure. It is a regular structure. Because of that regular structure, molecule have dipole momentum 0. Okay, not only this one. For example, if you go for another structures like methane or CCl4, if you go for CCl4, in CCl4 central atom C, it has a tetrahedral geometry. This is the tetrahedral geometry. So dipole vectors in this direction, Cl direction. All dipole vectors are equal. All are nu. Okay. These three dipole vectors resultant value and above dipole vector resultant value same, but are in opposite direction. So resultant dipole momentum is equal to 0. That's why even though it contains polar molecule, it is a non-polar. Even though it contains polar bonds, it is a non-polar molecule. Non-polar. Why? Because it has a regular geometry. What are the regular geometries? I will tell that one. If molecule type geometry and dipole momentum. So AB2, if I am taken AB2, if structure is linear, definitely it is a regular geometry. This is the regular geometry. Okay, their dipole momentum nu is equal to 0. Okay, the same AB2 if it is a angular or bent, in that case dipole momentum not equal to 0. It is non-polar molecule. Now it is polar molecule. Okay, it is for AB2 type. Next, AB3. Okay, AB3 means regular geometry trigonal planar. In the trigonal planar, dipole momentum nu, it is a regular geometry R. This is a regular geometry. This is also R. R means regular geometry. Regular geometry dipole momentum is equal to 0. It is a non-polar molecule. Non-polar. Next, AB3. Now, one is lone pair, that is angular geometry, angular or bent structure. We will have angular or bent structure. In that case, dipole momentum nu not equal to 0. That means polar molecule. Next, AB4. In AB4 type, geometry, actually it is AB2, it is ABE. Next one type, one bond pair, one lone pair. Next, AB3, first one AB3 in the trigonal planar, AB2E, that has geometry angular or bent. That means two bond pairs, one lone pair. AB4 tetrahedral geometry. Tetrahedral, that is the regular geometry. Dipole momentum nu is equal to 0. It is a non-polar molecule. Non-polar. Okay. Next, AB3E, that is a pyramidal structure. It is non-regular geometry. Dipole momentum not equal to 0. Molecule polar. Next one, if AB2E2, in this it is bent shape. That means two bond pairs, two lone pairs, bent or angular or V shape. In that case, dipole momentum not equal to 0. Molecule polar. Next, 5 bond pairs. That means AB5, 5 bond pairs, 0 lone, no lone pairs here. So that means TBP, trigonal bipyramidal. It is a regular geometry. It is a regular geometry. Regular geometry. In this case, dipole momentum nu is equal to 0. Molecule is non-polar. Non-polar. Next, AB4E. It is a T shape. T shape, it is not a regular geometry. These are not T shape. C sharp. Shape is C sharp. Geometry, it is not regular geometry. Nu is equal to not equal to 0, polar. Next, AB3E2. That is, it has a T shape. T shape is not a regular shape. Nu not equal to 0, polar. Next, AB2, that means two bond pairs, three lone pairs. Shape is linear. Linear shape, already I told you, it is a regular geometry. Okay. So nu is equal to 0. That means non-polar molecule. It is an exception. You need to remember this. Next, AB6. it has octahedral geometry. Octahedral geometry is a regular geometry. So dipole momentum nu is equal to 0. That molecule is a non-polar molecule. If AB5E, 5 bond pairs, 1 lone pairs, its geometry is a square planar. It is a non-regular geometry, nu not equal to 0. That means molecule, polar molecule. AB4E2. It is square planar, square pyramidal. Above one is square pyramidal. Now it is a square planar. That means nu is equal to 0. It is a regular geometry. Square planar regular geometry. Square pyramidal not regular geometry. So it is a non-polar. Okay, this information is useful whether the molecule is polar, non-polar. We can predict based on this geometries also. No need to calculate their resultant dipole momentum. So if you know this tabular form, if you know the number of bond pairs, number of lone pairs, if the structure is a regular structure, then molecule definitely non-polar. What are the regular structures? Linear, trigonal planar, tetrahedral, TBP, trigonal bipyramidal, octahedral, square planar are the regular geometries. Whenever a molecule have regular geometry, dipole momentum will be equal. Next, for example, if you take some molecules like I will give few questions based on this dipole momentum. So, for example, if we take NH3, NCl3 and NF3, which has highest highest nu for NH3. Why? Because see here in this case, I will explain this with the diagram. N on this lone pair, 3 H atoms. Next NCl3, NF3, here the N and H, which is more electronegative? N. So dipole vector in this direction, this dipole vector in this direction, and this dipole vector also in this direction. Now see here, lone pair electron cloud that more lobe towards away from the nitrogen. So that also have dipole. See here, a nitrogen electron cloud less, above that electron cloud more. So this dipole vector above. So these three vectors resultant dipole momentum will be in the upwards, and lone electron dipole vector is also upwards. Resultant value will be like this, highest value. But in this case, N and Cl, the electronegative difference is very less. Nitrogen 3.5, chlorine 3, electronegative difference very less. Here also pointing upwards, but NCl delta N less. Here delta N more. Okay. Now that's why the resultant dipole momentum will be like this. It is highest. Next highest this one. But for this NF3, N and F, which is more electronegative, F more electronegative. So electron cloud dipole vector in this direction. These three dipole vectors are in this direction. Lone electron dipole vector upward direction. Both are facing opposite. That means 180 degrees. So resultant dipole vector nu1. It is, let it considered nu1 or nu2. It is considered nu1. Resultant nu-r is equal to nu1 minus nu2. Whereas in two cases, resultant dipole vector nu-r is equal to nu1 plus nu2, because both are parallel. Bond angle of separation 0 degrees. So in that case, nu1 plus nu2. So that's way highest dipole momentum for new NH3, next new NCl3, next new NF3. Okay, next. For example, if you take a few molecules like this one, like this molecule, 1 comma 2 dichlorobenzene, 1 meta dichlorobenzene, ortho dichlorobenzene, meta dichlorobenzene, sorry, para dichlorobenzene, another one meta dichlorobenzene. They are dipole momentums. Already I informed you. See here, in the first case, the angle of separation. First vector is like that. Second vector will be like this. So theta is equal to 60 degrees in first case. In second case, two vectors are opposite to each other. Angle of separation 180 degrees. So in third case, the angle of separation will be 120 degrees. So we already informed that the nu r inversely proportional to theta. If theta increases, that means if theta increases, nu r decreases. Where theta is more? Here. So here actually 180 means both vectors equal and opposite were cancelled. So nu is equal to 0. Nu r is equal to 0. So which one has highest dipole momentum? First compound 1, next second compound, next third compound, least second compound. In that case 0. Why? Because theta increases means nu r decreases. When theta is equal to 180, nu r is equal to nu 1 minus nu 2. Here nu 1 nu 2 both are same. Both are CCl bonds. Okay. For example, in the same case, if we take a compound like this, CH3 and NO2. Next CH3 NO2. Next CH3 NO2. So in this case, give the decreasing order of dipole momentums. Resultant type. See here, this carbon is sp3 carbon, whereas this carbon is sp2 carbon, which is more electronegative sp2 carbon. That's why dipole vector in this direction. Whereas in carbon and nitrogen, which is more electronegative nitrogen. So now, actually, if you see this one, the angle of separation below vector is this vector is here, and another vector like this. So angle of separation here 120 degrees. Now we see this one, this vector downwards, this vectors in this direction. So this vector I am writing first vector like this, second vector like this. So angle of separation of 60 degrees. Next here this vector downwards, this vector upwards. That means both vectors are parallel to each other. Sorry. This vector also downwards. So both vectors are parallel to each other. So theta is equal to 0 degrees. So which one has high dipole momentum? First this one. Decreasing order means of all, third one has more dipole momentum because angle less means more dipole momentum. 3, next compound 2, next compound 1, least dipole momentum for the compound 1. Okay. Next, for example, if we take this compound CN and Out of these two, which has more dipole momentum? More dipole momentum for this compound. Why means I will explain now. This Cn has linear geometry like this. Okay. Now, whereas this OH, see this one out of C and this C, which has more electronegativity means this one has more electronegativity. So the vector direction is upwards. And out of these two, this vector nitrogen has more electronegativity. So same equal vectors, but facing an opposite cancels each other. Dipole momentum nu r is equal to 0. Whereas in this case, out of C and O is more electronegative. Vector in this direction. Here vector in this direction. Resultant will be in this direction. Resultant will be in this direction. They are not facing opposite to each other. So nu are not equal to 0. Here nu r is equal to 0. That's why it has more dipole moment. Okay. Thank you. That's all for this class.